Here we are looking at different examples of molecules that have 5 charge clouds. The bond between two atoms is considered a charge cloud, as well as a lone pair. So the total number of charge clouds is the sum of number of bonds and the number of lone pairs. Because there are 5 charge clouds, the electronic geometries of these molecules is trigonal bipyramidal. The molecular geometries differ because we cannot see the lone pairs. The molecular geometries are trigonal bipyramidal, or seesaw, or T-shaped, or linear. So you can see the molecular geometries vary, even though the electronic geometries are all the same. All the electronic geometries are considered to be trigonal bipyramidal. The atoms in the horizontal plane are in the equatorial position, and the atoms that are in the vertical plane are in the axial positions. So in this particular example, the blue are in the equatorial position and the green atoms are in the axial position. In this molecule, we have the central atom phosphorus surrounded by 5 chlorine atoms. In this case, the molecular geometry and the electronic geometry are identical because there are no lone pairs present. So our molecular geometry is trigonal bipyramidal and our electronic geometry is also trigonal bipyramidal. Here we are looking at a molecule with sulfur in the middle and 4 fluorine atoms bonded to it. There is also a lone pair on the sulfur. So if we count the number of bonds and the number of lone pairs, you can see there are 5 charge clouds. We cannot see the lone pairs when we look at the molecular geometry. We can only see atoms. But now if you consider the lone pairs and all the atoms, then we have an electronic structure which is trigonal bipyramidal. But now we can't see lone pairs, so the molecular geometry is seesaw. Because of the lone pair, we don't have a tetrahedral geometry. That lone pair changes the shape of your molecule, so the molecular geometry is seesaw. When we are considering the molecular geometry, we need to put the lone pairs on the equatorial position when there are 5 charge clouds. If there are 6 charge clouds, we would put the lone pairs in the axial position. For 5 charge clouds, your lone pairs have to be placed on the equatorial position to yield the correct molecular geometry. The molecule shown over here consists of 1 chlorine atom in the middle, surrounded by 3 fluorine atoms. If we count the number of bonds, which is 3, and the number of lone pairs, which is 2, we have in total 5 charge clouds. So the electronic geometry is trigonal bipyramidal, but the molecular geometry is T-shaped. Because of the lone pairs that are present, the molecular geometry is not trigonal planar. It is T-shaped because of the lone pairs. So even though we can't see lone pairs, they do affect the molecular geometry of your molecule. When we are considering the molecular geometry, we need to put the lone pairs on the equatorial position when there are 5 charge clouds. If there are 6 charge clouds, we would put the lone pairs in the axial position. For 5 charge clouds, your lone pairs have to be placed on the equatorial position to yield the correct molecular geometry. This example is a molecule consisting of 3 iodine atoms that has a charge of 3 minus. So we still have a charge cloud of 5 because we have 2 bonds and 3 lone pairs. So the electronic geometry is trigonal bipyramidal, but the molecular geometry is linear. We cannot see the lone pairs, but they do affect the molecular geometry of the molecule. When we are considering the molecular geometry, we need to put the lone pairs on the equatorial position when there are 5 charged clouds. If there are 6 charged clouds, we would put the lone pairs in the actual position. For 5 charged clouds, your lone pairs have to be placed on the equatorial position to yield the correct molecular geometry.